Grade 4, this is Miss Susan. Good morning, everyone. Today's topic is about line plots, lesson 12.5. And our essential question is,
how can you make and interpret line plots with fractional data?
Okay, so our today's topic is about line plot. And line plot is a type of graph that represents the frequency of any data on the number line by using or plotting dots or x's. And data here, the type of data is fractional data. So you can guess that we will use fractions. Okay, so let's see, and I promise you that will be an easier lesson. Let's start.
Take a look at how to use a line plot to solve a problem.
First, let's read together.
The data show the lengths of the buttons in Jen's collection. For an art project, she wants to know how many buttons are longer than 2/4 of an inch. Let's unlock this problem.
So first, what are the givens here? The givens here are the length of buttons in Jen's collection in inches. And as you see, they are all fractions and its all denominator is 4, right? Some numbers are repeated, like 1/4 is repeated 2 times, 4/4 repeated 4 times, 2/4 repeated 1 time. So that's why the data here are frequent, and that's why we represent it in the frequency table and we graph it in or on the line plot or number line by using dots or x's. Do you understand me? Now we will understand together how you do it. But first, let us ask, what does he want me to find? Okay, so she wants to know how many, the question here is how many buttons are longer than 2/4. 2/4. So let's see. First, the frequency table means let's see or represented by tallies how many is any data repeated.
A line plot is a graph that shows the frequency of data along a number line. Make a line plot to show the data. First, order the data from the least to greatest length. Next, tally each of the lengths. How many 1/4 of an inch buttons does Jen have?
So, we will ask ourselves how many is the number repeated. So first, 1/4. How many it's repeated here? 1, 2. So we will put 2 tallies. Do you remember the tallies? We count by lines. That's it.
There are 2 1/4 of an inch buttons. How many 2/4 of an inch buttons does Jen have?
How many 2/4 is repeated? It's 1 time, so we will put 1 tally.
There is 1 2/4 of an inch button. How many 4/4 of an inch buttons does Jen have?
We have 3 repeated 4/4. That's why we put 3 tallies.
Jen has 3 4/4 of an inch buttons. Now that you know how many of each size button Jen has, you can begin creating your line plot. The fraction lengths should be ordered on a number line from the least value of the data to the greatest.
So first, in the frequency table or the tally table, you have to order the numbers from least to the greatest. The same here on the number line, you have to order the numbers from least to the greatest. So the least number here is 1/4, then 2/4, then 3/4, then 4/4. Okay, you can't jump because the intervals here should be equal. So you can't say 2/4 then 4/4. No, excuse me, that's not supposed to happen. So let's see how he will put the numbers here or the number line.
Plot an X above the number line for each data point. How many tallies do you record for the 1/4 of an inch data point?
So 2 tallies, you will put 2 plots or 2 dots or 2 x's. So here we will use x's. We will put 2 x's above the 1/4.
Jen has two 1/4 of an inch buttons. How many tallies do you record above the 2/4 of an inch data point?
Just one.
Jen has one 2/4 of an inch button. Since Jen does not have any 3/4 of an inch buttons, there are no tallies to record for this data point.
So skip it.
How many tallies do you record above the 4/4 of an inch data point?
3. So we will put 3 x's.
Jen has three 4/4 of an inch buttons. Use the line plot to determine how many buttons Jen has that are longer than 2/4 of an inch.
So how many x's, which is longer than 2/4? What is longer than 2/4? It's a 3/4 and 4/4, right? So because we don't have any plots over 3/4, so we will count only 4/4. So how many x's over 4/4? Just the 3 x's. So how many buttons? 3 buttons.
Jen has three buttons that are longer than 2/4 of an inch.
Let's see another example.
Let's try another problem.
Let's read it together.
Some of the students in Ms. Lee's class walk to school. The data show the distances these students walk. What is the distance that the greatest number of students walk to school? Let's unlock the problem.
So first, see the givings. The givings here is 1/4, 1/4, 1/2, 3/4, 3/4, 1/2, 1/4, 1/4. So that's the distance the students walk to school in miles. Okay, so if you look here, the denominator is not the same. We have 1/4, 1/4, 3/4, 3/4, but 1/2 is a bit different. Why? Okay, 1/2 is a simplification of another fraction, which is 2/4. If you remember, can you imagine with me the number 2/4? And you simplify it by dividing by 2 up and down, it will give you 1/2, right? So you can just imagine that 1/2 is 2/4, okay? Let's see first here, after seeing the givings, see what is the question is. The question is, what is the distance that the greatest number of students walk to school? So we will see which distance has the greatest number of x's on the line plot. So first, draw the frequency table or the tally table and see how many times each distance repeated. So first, tally table, and we have to order the numbers from least to the greatest.
Make a line plot to show the data. Begin by ordering the data from the least to the greatest distance. Then tally each of the distances. How many students walk 1/4 of a mile to school?
Why we put again half in the middle? Because half here is equal 2/4, 2/4. That's why in order we should put 1/4 first, then 2/4, then 3/4. Now let's put the tallies. How many times does 1/4 repeated? 1, 2, 3. So we will put 3 tallies, mean 3 lines.
3 students walk 1/4 of a mile to school. How many students walk 1/2 of a mile to school?
How many students walk 1/2? So we have 1/2 2 times. This means 2 tallies.
2 students walk 1/2 of a mile to school. How many students walk 3/4 of a mile to school?
Repeated 2 times. That means I will put 2 tallies.
2 students walk 3/4 of a mile to school. Now that you know how many students walk each distance, you can begin to make a line plot. The fraction length should be ordered on a number line from the least value of the data to the greatest.
So first we put 1/4, then 2/4, which is half, and 3/4.
Record the tally for each data point on the number line. How many tallies should be above 1/4?
We should put 3 X's.
3 students walk 1/4 of a mile, so there are 3 tallies. How many tallies should be above 1/2?
2 X's.
2 students walk 1/2 mile, so there are 2 tallies. How many tallies should be above 3/4?
2 X's.
2 students walk 3/4 of a mile, so there are 2 tallies. What is the distance that the greatest number of students walk to school?
The most students here are above 1/4 because we have here 3 students above 1/4. So the distance that walk mostly is 1/4.
Most students walk 1/4 of a mile. Ready for another problem?
Let's do it. Okay, read it together.
A food critic collected data on the time customers waited for their food. Order the data from least to greatest time. Make a tally table and a line plot to show the data. Order the data from least to greatest time.
Okay, now first 1/4. Then 2/4, which is 1/2. Then 3/4. Then what is 1? Bravo, 1 is 4/4. So after 3/4 come 4/4, which is 1 in all, which is the whole number. Do you remember it? Let's check.
Tally each length of time by dragging each tally to the correct row within the table. Tallies may be used more than once.
Let's see how many times is the number repeated.
That's right. The tally is equal to the number of times each value occurs within the data. Complete the line plot by dragging the correct number of X's for each tally onto the number line. That's right. The number of X's for each data point should equal the number of tallies within the tally table. Using your line plot on how many customers did the food critic collect data? Enter your answer in the space provided.
Okay, so on how many customers did the food critic collect data? So he collected 2 customers for 1/4, who choose 1/4, and 1 customer here who choose 1/2, 3 customers choose 3/4, and 2 customers choose 1. So the number of customers in all are the numbers of X's in all. So let's count how many X's do we have here over the line plot or along the line plot. So 1, 2, 3, 4, 5, 6, 7, 8. So the number of customers in all is 8. Let's check.
That's right. The food critic collected data on 8 customers. Using your line plot, what is the difference between the longest time and the shortest time that the customers waited?
Okay, so the longest time here is 1 and the smallest time is 4. So if I minus 1, which is 4/4, minus 1/4, so how we minus fractions? Keep denominator, add or minus numerator. So we will keep the denominator, which is 4. Then we minus numerators. 4 minus 1 would be 3. So the answer will be 3 up, which is the numerator, 4 minus 1, and the denominator will be the same, which is 4.
That's right. The longest time customers waited was 1 hour, and the shortest time was 1/4 of an hour. The difference between 1 and 1/4 is 3/4. So the difference between the longest time and the shortest time that the customers waited is 3/4 of an hour.
Thank you, grade 4, for watching. Wait for me for another lesson tomorrow.
Thanks for
See
helping
you.
me show Seeley how to make and use a line plot with fractional data. Now he can compare his bugs more easily. See you again soon.
Bye-bye.